So welcome to the second class of data analytics this autumn or fall of 2024, right? Now, if you take a look at class schedule, this sort of class plan kind of tracks this book that I wrote to be used as a textbook specifically for this class. In fact, I wrote this. The textbook is kind of based on a lot of little snippets of notes that I have used to demonstrate various mathematical or data science concept. I kind of like compiled them together, but in the end decided to make a whole sort of like a cohesive interactive text designed basically for this class. So the class outline will pretty much follow the book outline. What I might do, in fact, is take a little bit of module, add on, and subtract. For example, next week, we may start with interactive visualization, although we might actually start talking about your own term project, sort of like bring up this kind of project brainstorming early in the semester. What I found is that when I leave that toward the end, sometimes there's a little bit of, I wish we had a bit more time to think about it or incorporate various bits. So we'll see, okay? So this is basically the class outline, although we should be flexible. Again, this is the textbook that's going to be coming out. In fact, the department secretary is supposed to send this to the publishing house today, and it should be here in a couple of days. Meanwhile, there are supplementary texts. Again, look at this. Some of this I do have, like I said, private or my own PDF or scan or digital version of all this article and some of the textbook. So if you're keen on that, come see me or your TA. Some of these could be a little bit dated, but by and large extent, data analytics is you can say it's sort of like a mature field. Data science and data analytics is a mature field. There's always innovation and new technology and new techniques coming out every year, especially with AI and large language model. But certainly the framework, the workflow, the principle, pretty much all these textbooks have outlined will still be very much valid. Okay, so let's get to our textbook. Now, again, last week, do read a little bit of prologue introduction. I gave you what's just a header file, so to speak. Okay, what I want you to do is just basically go here and shift enter. It's basically a code that set some of the default, basically display kind of thing. So it's not that critical to the learning. Having said that, it does help shortcut the display function. For example, I create a function called table. Yeah. So I have like a function called table. So it's basically just a grid display, which is a standard built-in function, but I have already I specify sort of like a special format like bold color, blue or something like that. This is to make things look nice from my point of view. Likewise, this information we'll see in the probability class. There's a lot of summary information about probability and statistics, right? Like if you go to Wikipedia page, we can do that right away actually. Let's go to right, Wikipedia. Let's say gamma distribution, right? So basically, if you go to this page, there'll be a lot of summary box here. It's kind of that sort of thing, right? Except it's even more summary, more of a summary. So I give this thing called information about the distribution, mean, variance, and so forth. And then there's a lot of graph layout. You don't know about this yet, but in graph theoretic, there'll be some display. oh, this thing, sometimes you get warning or error message that has to do with the fact that, say, for example, this function called local time is accessing the internet. So maybe we couldn't get to the internet right now. That's fine. It's not a big deal. Right. So last time we went through the conceptual baseline of what data science and data analytics is all about, right? Like I said, I'm very good at two things. I make difficult things easy because I give it intuitive understanding of how things work under the hood without you being the technical person. But the opposite end, I also do the opposite, which is to make easy things difficult. Let me see, there's a bit of an echo here. Let me, okay. Yeah, the opposite end is I tend to make easy thing difficult, which means that very simple concept that you take for granted, you know, what's data, what's a point, what's experiment. I try to sort of like milk it for the full extent of what it means, what it implies. All right. So I want you to delve dig deep into the definition. Okay. So spend quite a bit of time on, you know, just what does intelligence mean, right? There's intelligence in artificial intelligence, business intelligence, computational intelligence, right? So to an extent, that's basically the text that the text portion of this textbook. Basically, chapter 1 give you the understanding and covers all kind of again foundational understanding, some of which, like I said, sometimes you even professional data scientists ignore, and they shouldn't. In particular, I'm very annoyed when I see data scientists try to build, say, machine learning model that feeds off or is only able to provide, let's say, ordinal evaluation, like A is better than B. But the model that's built somehow generate some kind of distance. How much is A bit better than B, which is not valid, right? It's not valid. You can say that Miss Universe is more beautiful than the runner-up, but you can't say the Miss Universe is more beautiful than the runner-up to the same amount as the difference between the first runner-up and the second runner-up, right? It's no such thing. So if data scientists try to make conclusion that really is only valid if you have, say, a full interval ratio or interval or ratio scale variable, but actually the variable that you produce is only ordinal, maybe even worse, nominal, right? That's like saying one student is better than the other one because the student ID is bigger. Okay, it's silly. So do pay attention to that. And so I'm okay. Now, I already showed some of the capability of Wolfram Alpha in that chapter, but to an extent, we have covered that. So today we go to the second chapter. Okay, so this was last week, right? Okay, let's sort of like collapse some of this. Okay. So last week was chapter 1. So let's go to today, which is chapter 2, right? Now, this is an introduction to Wolfram Mathematica. There's actually two words, right? Wolfram and Mathematica. Well, you can think of it as last name and first name, right? In fact, Wolfram is the family name of the of Peter Wolfram, who originated the whole thing. And Mathematica is like the language, the computational software, right? But then you can think of it as having this kind of like ecosystem. So maybe you can think of Wolfram as the ecosystem. It has the data, it has pre-built model, it has some kind of curated data set, has intelligence information, and ultimately Wolfram, in the guise of what's called Wolfram Alpha, is what ChatGPT connects to, right? briefly, if you go to ChatGPT for a free account, as with most language model, Gemini and whatever, Claude AI, you would get like a short session, and it also doesn't do much besides giving you the response. But if you want the AI to work as a resource compiler, in other words, ask the AI to go fetch something from the internet and then write some code that sort of like screen out some information, that sort of thing, or make a graphical plot, or do some kind of regression, any kind of computation, any kind of additional functionalities, this will be considered quote unquote ChatGPT add-on or add-in or add-on, okay? And one of the major, in fact, it was at the time I last checked, the most important or the most popular add-on for ChatGPT is Wolfram Alpha. Now, of course, you get a free version of ChatGPT, you can't connect to the add-on. You have to have the GPT Plus or subscription. And similar kind of thing probably work with Gemini, with Claude, and all kind of stuff. Where if you just want a quick conversation chatbot, it's free. But if you wanted to do something else, you know, start writing code or user interface design or something more, I guess, professional, then you have to pay for a more pay for like a monthly subscription or something, and then you have like a larger bandwidth and working environment. Anyway, okay, so but you see, I'll go through the detail. So let's see what it is. Okay, so first of all, the very first thing is to introduce you to Mathematica. Okay, so forget about what I said about Wolfram, except Wolfram is the name, the last name of the physicist who wrote this. You can think of it here as a scientific computation platform. In other words, well, what scientific computation? Well, it's computation that's, first of all, probably going to use a lot of math, calculus, partial differential equation, all kind of stuff, right? But these days, scientific computation would go to things like simulation, right? Things like computer-aided design and engineering, all kind of stuff would be considered computational. Ultimately, it comes back to mathematics, but it's not framed as, you know, as equation or partial differential equation, right? So all this, when you get the book, follow the URL as well. Okay, so for example, well, we can do that. Shift enter, right? So that's the whole world of Wolfram Mathematica. It gives you all kind of introductory stuff. Okay, so all kind of example. Leave a message. I don't want. How do I get rid of? Anyway, so obviously software is going to have all kind of ads. Right. Yeah. Okay. Right. So basically, there's a timeline. This is very interesting. Recently, not recently, but maybe in the past 5 years or so, not Peter. My deepest was Stephen Wolfram. I don't know why I got Peter. Stephen Wolfram, you know, as he's getting, well, he's probably retirement age now, so he gets self-reflective. He's still very active in research. In fact, I can talk to you about Wolfram physics program, very advanced stuff. But he gets a little bit self-reflective when he gets older. So he write about, you know, what was it like when I wrote this way back in, say, 1988 or something like that. So it's kind of like a memoir. It's very fun reading. Anyway, so Mathematica 1, I guess, was the story. The idea was this. At that time, he was a physicist. So he wrote a language for himself to use as a physicist. Okay. So what do I mean by symbolic language? Well, first of all, it has to have understanding of things that are pure symbolic in I guess in this case, mathematical scientific sense. So if I give you a concept of E, do you guys know what E is, right? Euler's number. It's like a universal number. Even if you do finance, there's Euler's number, right? Well, let's say you're doing some kind of proper, you know, programming language like Python, C++, blah, 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 right? You would have to sort of like think of this as as a finite precision number. Okay, so E would be 2.71 something something something. Okay, down to maybe 16 decimal places. I don't know, 32, whatever. Okay, 20 decimal places. So that would be a numerically stored, sort of like a hard code value of what an E is. Okay, but in Mathematica, this E would actually stand for this concept of E. You can ask it, what is it approximately equal to the first two decimal digits? Okay, 2.71. But actually, it's a transcendental number. Now, you think this is not a big deal because, well, you know, what's the difference between actual E and 2.71? Not much. But what about infinity? We'll see today that, you know, this scientific computational platform understand what it means to be infinite. Okay, so you can't store infinite in any kind of C or Python language. Okay, and we'll see. Okay, but the idea was that there was a need to do sort of like a symbolic. It's like solving equation the way you did something like in algebra, right? 3x is equal to 7, right? And then what's x? Or 3x plus 7 is equal to 0. What's x? Well, first you sort of like move 7 to the other side and you divide by 3, right? But how do you do this conceptually so that it doesn't matter what number it is? It could be ax is equal to b, or it can be polynomial equation. It could be something more complex. So literally something with mathematics. And that's why in the early days, it was a tool of physicists, mathematicians, engineers. But of course, so this is kind of like I make a memoir excerpt. Very good. Anyway, so I kind of personally, if you read the prologue, I didn't use Mathematica when I was your age either. My PhD thesis was about what's called evolutionary optimization, which means that I simulate nature's evolution, except instead of simulating survival of the species, right? So that giraffe evolved long necks so they can eat the top leaves, right? Instead of survival in the desert as my challenge to the evolution of species, I would give a practical problem. Problem is to buy and sell currency in a way that makes money. Okay, so that was algo, you know, what you guys would call today algo trading. So this becomes my quote unquote survival challenge. And then I simulate a bunch of trading rule and see which one sort of like sticks, which one makes money, and then reproduce and make children that has that characteristic behavior and so forth. Today, my problem would be studied under the rubric. Most people anyway who are active in this kind of research area would probably approach it as what's called reinforcement learning or reinforcement machine learning. Okay, but like I mentioned last class, reinforcement machine learning is not within the scope of data analytics because it's not the bulk of it. Okay, right. So anyway, so my PhD was about evolving objects in virtual nature. Right. So what I did was use what's called object-oriented programming language, in particular C++. And my own advisor, thesis advisor, the brilliant Professor Antonia Jones, who sadly passed away about a decade or so ago, maybe 15 years. She was using Mathematica for some of the advanced stuff. She was herself a mathematician who turned to computer science. And a lot of her students use them. I think it was Mathematica 5 or something. And I didn't because first of all, I didn't like the computing paradigm that it's based on. Again, we'll talk about that later. And secondly, because object-oriented was more consistent with what I was trying to do with my thesis. So I did. And I only came back to Mathematica, I think when I was working for the Bank of Thailand. I invented a new I wanted to invent a new mathematical function that model very non-linear relationship in which one variable at that time was financial market. So two financial variable may sort of like correlate in a funny way, okay? And correlate in a funny way mathematically is called copula, okay? I kind of invented a non-linear copula, but you know, having a good idea is it's just only the beginning. And that's why I tell Basai student, having a good idea is just, you know, 5%, okay? I have to sort of like work through the mathematical consequence to make this viable. And long story short, it came with some horrendous, you know, polynomial exponential function that I needed to integrate from minus infinity to plus infinity. I didn't have enough mathematics to, you know, I couldn't do this in a lifetime. So I tried Mathematica as an analytical symbolic engine. So I put in this equation. I asked it to integrate, which is find area under the curve, from minus infinity, literal infinity, not numerical infinity, right? From minus infinity to plus infinity. And it got sort of like semi-analytical form for it. It was something that was impossible to do anywhere else. I couldn't do it with MATLAB. I couldn't do it with C++. I couldn't do it with obviously Python. I couldn't do it with you know, Visual Basic. And definitely nothing. And it kind of like got me hooked in the way that by that time, you know, Mathematica also got into a lot of visualization, visualizing mathematical function, interactive visualization. I kind of like, hey, this is very good because I needed to build up my quant team as well. And I need to sort of like, you might call it like a public education, give private talk and stuff. And then, so I became concerned not only with pushing the idea of what mathematics could do in my analytical problem in financial sector or banking sector, but hey, how do you communicate concept of mathematics in an easy way? That's sort of like I wasn't conscious at the time, but for some reason that, you know, that period 10-20 years ago laid out the foundation for me to, you know, end up trying to give you this intuition behind mathematics at Basai. Okay. So anyway, so I think there was so that would have been like Mathematica 8 or something like that, I would imagine. Okay, so that's sort of like where sort of like the origin story, right? The origin story. Now let's talk about here. This is the notebook, and again, this is double click this. It takes you to basically help page. Now, if you got the Mathematica install, the help page hopefully is stored as on your computer, so you don't even need internet. But the textbook here, so here, this thing here that says reference wolfram.com/language. This is going to the internet. So obviously, if you have internet, you don't have Mathematica, you can use this. But you will notice that if you go to a help page within your software, it doesn't need to go to the internet. I think it's stored locally. I'm pretty sure. At least for my, I'm not sure about student version, but for me, especially. Okay. Well, the concept is this. Now, think of computer programming. You have to tell computer what to do. It can do a lot of things, but you have to be precise, right? Because if you give it the wrong instruction, it can have very unintended consequence, because things we take for granted, right? So, you know, say, where's the bathroom? Turn right. Okay, for us, it makes sense that, you know, you go out the door first and then turn right. But if you tell the, let's say a very dumb robot, programmatically, as it turn right, it hasn't gone out the door. So when it turn right, it hits the wall. Okay. So anyway, you need to program the language. Now, one of the, you know, from your earlier generation, even before my generation, the main thing was called procedural. It's a little bit like a cooking book. It tells the step. Do this, do that, you know, do this, do that. Right. Well, with Mathematica, you and when you talk about procedure, back then it was based on what's called compiling language. That means that you write a whole bunch of instruction, in semi-English, but basically computer code that has some English words. And then you ask the computer to compile it. Once it compile, it becomes a computer readable, executable that you can't read, but it's all in binary. You send that binary to an actual computer and it does things. Okay. So there's a kind of like, you have to finish your whole instruction set, compile it, give it to computer, right? On the other hand, at the same time, you have this thing called calculator. Now, calculator is very interactive because it doesn't listen to long instruction set. It gives you the response right away, okay? So 2 plus 2, then it's a 4, whatever, right? Now, the downside of a computer is that if it's not a programmable calculator, then it can only do immediate response, okay? So there's always a balance between this immediate thing and this long instruction thing. And to an extent, when we talk about ChatGPT, it's that as well, okay? Gong Gan here is going to teach the other class, apply AI, this thing called agentic workflow. This is sort of like setting up an AI to be like a separate agent that has a programmatic loop or kind of long thread work process, workflow, okay? So the balance between getting immediately the answer you want versus something more complicated, but very elongated. That's always been with us when we started use computer. Okay, so think of long compiling language on the one hand, and then calculator on the other, right? Well, in the middle, there is this thing called functional programming, which is very elegant because if you want to use something very simplistic, again, I didn't use this for my PhD. My PhD was about this whole evolution big. So I was using C++, so that was a compiler language. Right. But with this thing called functional programming, what it means is that if you want something quick and dirty, 2 plus 2, yes, it's equal to 4, right? And then it has a whole bunch of functions that does more complicated, but it's still a one-shot deal. It's still a one-shot deal. You give it X, it does something maybe complicated, maybe it takes minutes or hour, but it does give you back Y, right? So if you think about it, if you have a computer dialogue that's based on function, okay, based on how that function is defined, it could be one stop 2 plus 2, or it could be a huge complicated algorithm. On top of that, if you are able to put a whole bunch of functions together, so now your procedure is not detailed how to do this and that, but sort of like a well-structured way of calling various functions. First call this function, get some result, and based on this result, maybe call another function, do something else, and maybe get some result, maybe do something else, maybe get a function, right? So you have this supreme flexibility. You can do something quick and dirty. And if it's a built-in function, even though it's complicated, it may be in Mathematica, you see a lot of complicated function is called in one sentence because they wrap the whole thing as one function, right? But then you can build on it because you get that function as a result. You're not happy because that's not all you want. Maybe you call this one function, you call another function, you get the result of those two functions, you put in the third function to do something. So you can string functions together, okay? And that's basically what functional programming paradigm is. You communicate with computer fundamentally by calling functions. Now, we will see that there are two types of function. There are very ubiquitous garden variety function, mathematics, maybe computational. So these are called built-in, right? Again, built-in function are not good enough for your particular application. You have to specialize it, right? So call this built-in function, call that built-in function, call this built-in function, call that built-in function, produce the result. Well, it turns out the whole thing that you just constructed can be thought of as a function, right? So why not wrap the whole thing, call it your function? That's pretty cool, huh? So you can build complexity up. Okay, this is something that calculator cannot. Can't build up complexity. This is something that compiler language can do, but it's very tiring because pretty soon you have a code that's 10,000 lines, then you have to build on this, you get 1,000,000 lines worth of code, right? And you sort of pretty much have to have all the codes together, pretty much. My PhD thesis, if I'm not mistaken, is based on 7,700 lines of code. I think, I'm not quite sure. It was C++. Okay, and that's already high-level language at that time, by the way. That was pretty cool already. That was like a lot of built-in object. So think about this kind of concept called functional programming. Functional programming, right? Now, that in itself is what a lot of you grew up with, which is Python. Okay, now Python is one of those languages that you can write or converse with it in an object-oriented paradigm sort of way, yes, but it's not natural. The most natural way to think of, can I say that? It's more natural to think of Python as a functional programming language. Now, same with C++, right? C++ is the most natural language to do it with object-oriented. But if you want to do it procedurally, I'm sure you can do it. It's just not natural, okay? And then there's something more high level, I guess, declarative language. That's like, instead of telling computer what to do in a procedural way, instead of defining a function or using a built-in function, you sort of give the computer the intention. And this is what the future generation, you know, the way you deal with AI is sort of like this. I would like to have something like that. Okay, whatever, do what you like, do what you can, get me one, get me an ice cream with a nice, a lot of toppings. Okay, it's kind of like a high level instruction. Good thing is Mathematica, okay, like Python, is very much a functional kind of language. Okay, it's most natural when you converse with it in that way, but it's also in a way more of a declarative language. So it wraps a lot of details, you know. So if you call this function, call that function, call this function, and function has to be supplied with this parameter and that parameter, it's very tedious. So sometimes it's sort of like second guess you that, well, if you don't say anything, you just give the intention, this is probably the function you want, and this is probably the default setting you like, and you want to make it, you know, super cool, super customized, fine. But if not, I'll just give you a starting point. Okay, so that's more like a decorative flavor. And that's why the Mathematica is the right language, at least I think for using this Basai. Because for some of you who are not going to apply digital intelligence, if you go to apply digital intelligence, you need to learn Python. Otherwise, you would not have any friends, right? Because the world out there is a large community of Python. But if you work in, let's say, health and well-being, sustainability, sometimes you want to prototype some idea. You want to be more like a decorative, okay? So you will have two tools, something more analytical, more tangible, more computational. You have this Mathematica, right? To prototype some calculation about, I don't know, metabolomic pathway or whatever. For something else, everything else that's more like natural language query, then you go to large language models. Okay, so hopefully, if you're not like a specialist or, you know, coder, if you're working in sustainability project or health and well-being, hopefully between this kind of high level Mathematica tools and something, you know, that's has a computer liaison in the guise of large language model, then you have a complete sort of tool to get your project going. Right now, so let me start. So you start a notebook, okay? It's .nb, obviously, right? You will notice that, let's start a new notebook, okay? When you enter something, 1 + 1, shift enter. Well, first of all, if you enter, right, you just go to the next line, you have to shift enter. Now, I want you to notice a few things. Okay. The minute you start saying something, it becomes input, right? Apparently, this is input 11. So I've done 10 previous input, and this is output 11. Okay. And if you look to the right, you will see that there's this kind of like a square bracket dish to sort of like group things together, right? So you can sort of like hide the input, or you can hide the output. I don't care. The whole thing, this thing is the input, this is the output. Together, this is a input-output pair, right? And this kind of cell, this kind of elemental unit is called a kernel. Okay, kernel is an English word, comes from the word seed. It basically means seeds, right? So you have a whole big fruit. It's composed of tiny kernels of corn or something like that, right? So likewise, this is kind of like a kernel way. So what you can do is you start a new line. It becomes something like, I don't know, exponential 1, 2, 3 or something like that. Okay, whatever. Okay, so that's another kernel, right? But you certainly can say, well, this is something that's together. Now, this is a mathematical input-output, right? So that's by default what happened when you key in something. But notice this add addition line, this plus sign. If you click to this, okay. So by the way, I want you to actually do this as I go along, right? So again, whenever I type in something, it's going to assume almost by default, unless you set some default some other way, that you're going to be talking functionally, right? So this is a function. This is a function. This is a function add, right? That's applied with 2 arguments, 1 and 1. This is a function called take the exponential, right? It's applied with 1 argument or 1 input, 1, 2, 3. Okay. So this is what I mean by functional. Now, if I go to over here and see the plus sign and click on it, there are different input mode you can do. So the first one is obviously the default. That's you know, entering a mathematical command or function, right? But if I want to put in a plain text, I can do that, right? I can put other style of text. So let's go to this. So this is like a word processing kind of thing, right? So this is kind of title. I don't want title. I want it to be let's say section. Let's call it this a section. Call this a section. Okay. My example, right? Now you will notice that this section has its own kernel, but because the way I wrote it, this thing precedes this, and it does make sense to bunch things up together. So this become like one kernel. Okay, this is the concept of kernel. Okay, now in a more sort of like elementary way, sort of like a not too hierarchical, you will have seen this if you took Python programming class and your class used Jupyter Notebook. Okay, raise your hand if you've done Python programming. Raise your hand if you use Jupyter Notebook. Okay, well, the one who created Jupyter Notebook basically got idea from Mathematica kernel. So that's why it looks similar, okay? But you can say that, you know, Stephen Wolfram came up with it first. So anyway, so my textbook, because I write it in the Mathematica file, you know, I can sort of like, I can print the screen if I want, but I don't want this thing, so I can kind of collapse it, that sort of thing, all right? So it's kind of like very, first of all, interactive in that sense. You can literally hide details and so forth. By the way, this thing about, you know, being say like this is an item, this is a section and so forth. It has a default format. Again, everything tends to have default. If you're going to define it some other way, then obviously you can configure it. Raise your hand if you heard of LaTeX. Okay, well, LaTeX works in that similar thing. You know how this is a side note, but I might as well give you understanding. LaTeX kind of like born out of academics' need to publish, right? And here's the thing. It's not a trick. It's really what happened. When I was a student, PhD students, right? Well, first of all, if you're ambitious, you can publish in journal, but that takes a long time. It's very difficult. to get the journal passed, but it takes a long time as well. But if you publish in conference, it's very quick. You get a quick feedback, and your work may not maybe like a next step, but not the complete step. You have not, you can present at a conference. And additional bonus, I was a skilled student on scholarship, and also, the department has some kind of funding, I think. If you choose your conference right, you can go to a conference that happens in a very nice city. Okay, and maybe your sponsor or your university will send you there. So when I was in London, I wrote one paper in to Istanbul, another paper in Hong Kong and New Zealand and so forth. Well, imagine that every conference has its own formatting requirement, right? And when you send maybe the same paper, you're not quite sure if the conference in Istanbul is going to like it, but the one in France may not like it or something like that. Sometimes you might send basically the same paper to 2 different conferences, right? Now, what would you do if you did this in Word? And this was in my year. You have to change all the format, right? Now, to do it programmatically, what it means is that I write one text. I designate this as a title. I designate this as a section. I designate this as equation. I designate this as bibliography section, right? And depending on which conference, they'll have what's called a style file that say, okay, the header should look like this. Use Cordia New 17-point header. Okay, the subsection would be Cordia New 14.5 point. You don't have to change every single one of them, right? You just sort of like, so this is kind of like that. Anyway, so that's so the concept of notebook kernel, okay, go 1 + 1. Again, I wrote this before. Now, if I haven't executed, notice it's just gonna say, because this is from previous iteration, it already has an output, right? If I wrote it for the first time, I wouldn't have an output, but this output is saved, just saved as a number. But right now it means nothing to this particular notebook because I haven't shift enter. So this is like a date text, just sort of like a legacy from the last session. Now, if I did this again, shift enter, notice because I already did 13 for 11, 12. So this is 13. Next time is 14. Okay. So just keep adding. Some people, this is kind of like, my thinking is that this is kind of like a legacy from when people really like to refer to lines of code. I don't know if you know what the basic language is. Yeah. That was my first programming language. You literally go to line 007 or something. But I tend not to use line number. Anyway, this here, 1 semicolon 2, what do you think is going to happen? Well, this semicolon is sort of like a silence kind of thing, because if I put in 1 and shift enter, it's going to print out 1, right? Now, if I separate like this, what do you think is going to happen? Well, you know what? I should do this. Cell, delete all output. So you guys don't see what the output is. Basically, it deletes all the previous output. Okay. So now I can ask, what do you think will happen? Okay, because just now you knew what happened. So it's going to say, I enter 1, that's an input. What's an output? It's 1. But then I put this semicolon, say, go on, go to the next one. So that's 2. Now, when I shift enter, it becomes a new instruction. So what happened here is that I make 1, 2, 3, 4 input, but it's only going to echo back 2, just this guy and that guy. Right? So input, output, again, input, this is how you talk to the computer with a function. But in this case, that function is just a number. So it doesn't do anything. It just say echo back, right? So there it is, right? So output number 15 is 2. Output number 16, which is the next line, okay? This is not an output because it doesn't get to output. This is not an output because it doesn't get an output. Internally, yes, it does receive the word 1, but it does nothing. Okay? So sometimes you can do something else. Okay? So this is also built in. we'll see later. Then different kind of function call. If you type in blue, type in blue. Okay, type in blue. Now, first type in blue with small letter blue, B-L-U-E. B-L-U-E. Oh, by the way, this is my textbook. So by default, I set it to text. So because by default, set it to text, I have to do this. Okay, but okay, let's do this. B-L-U-E. You notice two things. You notice two things, right? First of all, it gives you a autocorrect. So it's trying to sympathize with what you like to do. And this is very common with IDE, integrated development environment. Okay. But you actually didn't type in right because by convention, all built-in function in Mathematica start with a capital letter. So I start with a small letter. It doesn't know because it's not a built-in. Okay. Notice that as I type in, what color is this? Well, it's actually blue as well, but I can type in red. It's also going to be blue. Blue means something that is not yet defined. Okay. It's like HTML URL usually has bright blue. This is sort of like a not so bright blue and not underlined. Okay. So this thing doesn't know what it is. Okay. You give it something it doesn't know. It's blue. Okay. Let's try. Shift enter. What? It doesn't know. It just echoes back because it has no idea what it is. Has no idea what it is. And this thing is still blue. Okay. Now, I'm going to do something that doesn't make sense, but I'm going to say red is equal to blue. But now, notice that I type in big capital blue. What happened? The letter is black because it knows what it is. Because black is a built-in, because this big B-L-U-E is a built-in function. It's a function that doesn't take any argument because it knows what blue is. So there it is. If I did this and shift enter, okay, notice two things. It outputs a color because this thing here corresponds to color. What else happened? That red thing is now in black because effectively you define it. So now if I type in the word RED, okay, if I type in again RED, right? Sorry, I keep getting R-E. Now if I misspell it, it's going to be blue, right? But if I spell it right, it's going to be black because it knows what it is. Is it going to give you the color red? No, because you define it as blue. Okay, so play along with this. Now, I'll show you this later, but I couldn't help right now. If you put your mouse on here, you would see what it says. Can you guys see it? It says RGB color 001. Hey, that gives you an idea. Maybe this thing here is a function, and that's what it is. Okay. Now let me do this. Okay. This is an output, but I double click on it. And I do this. Okay. So anybody knows what a purple is? A purple is a 101, right? So let's make it purplish. Okay. Yeah, it looks like a purple, right? And all kinds of stuff. Anyway, so this is basically RGB. Okay. This is RGB. So now let's just make it more green. Okay. Done. Oops, sorry. Okay. So I just make it green just for fun. Okay. Okay. So now it's green. Look, see? Now it's 0, 1, and 0.5. In fact, if you go to a separate line and key it yourself, RGB color, now you can put in any three number you like. Okay. So 0.1, 0.1, 0.1. What do you think it's going to be? 0.1. Okay. The RGB is given on a scale from 0 to 100. So 0.1 is pretty low, right? If I give it pretty low and I give it red equal green equal blue, what do you think you're going to get? It's going to be very dark, right? Right. On the other hand, if I make it 0.9, well, forget it. Let's do this. Let's multiply by 9. Oops, sorry. Oh yeah, you can. I'll show you how that's done later. Okay. Right. Now you can do all kind of stuff. Make it darker. It doesn't matter. So this is kind of like fun and games. So go back to where we were. So those are things. So in other words, not only is this high level, it can deal with things that are not necessarily numerical, right? Now, this is very important, guys, because when this was kind of invented, this concept of multimodal input was like 20 years ahead. So back then, computer only takes two things, numbers and letters, strings and numbers. So to put in color or to output color, to put in a concept of color makes no sense whatsoever, right? The idea is of this high level multimodal is this, okay? If you think about English language, okay, you use the word big, okay? You can use the word big applied to a cat. You make big cat. You can apply the word big to the word mouth. You can big mouth, talks a lot. You apply the word big to object, it becomes a big object, right? The objects are different, but there's a natural language way of thinking about big, right? Mathematica tries to do this kind of thing. So if I have a function called plot and the object is a line graph, it's going to plot a line graph. If I want to plot and the object is sort of like a 3D rendering of some object you're going to print later in a 3D printer, it's going to try to display that, right? So this kind of like one word applied to different thing in object-oriented speak is called polymorphism, but you don't have to worry about that. Anyway, but the concept here is that I want to show things, but things don't have to be words. And this is why this tool is much better for you if you're gonna do it like a health science or something than Python. For example, this is my example. Okay. Now you can type in with me, but don't worry. This table here came from the header. So this is my predefined function, but you don't need predefined function. So let's just do this. You can just key in this chemical data. Okay. So let me do for you. Okay. Chemical data. Okay. And this is where you don't just get the programming language, you get some sort of like a knowledge base as well. So this is getting into the bigger Wolfram ecosystem. So let's say I'm just going to do this. Okay. Let's say I open up and say I put in a double quote. It has autocomplete because these are the sort of like popular or the A starting chemical data. So, but anyway, I don't want this. I've been drinking coffee, so I'm not going to there's caffeine, right? So if I type and it's there, chances are it's there. But if I type randomly, like it's gonna, I don't know what this is, right? Silly, I don't define. So CAF, there it is. So tap, so that becomes caffeine, right? So let's do this first. Let's just do this. Chemical data, caffeine. Shift enter. Now, the first time it does this tends to take a little bit long because the first time you do this is when you tell the session to go to the internet to establish a pod. See, there it is. This is literally the default display of a caffeine, right? So you don't have to go look up, download, go to Matplotlib or some program in Python to draw a picture. It's there. Now, because again, as a high language, it knows certain things. So molecule plot or something like molecule plot 3D, it's going to give you another picture. So something like this, right? So this is something that can already be rotated. In fact, you know, with a couple of steps, you can then turn this into a 3D printer instruction and send it to a 3D printer. It's going to print this. Now, it's not, your 3D printer is not going to be able to color it. Can you? Oh no, not the one we have. The one we have is just going to give you a, that's just one color of the plastic, yellow, white, whatever. I'm sure in advanced 3D printer, you can put in different colors and specify for this part, use, you know, but yeah, so there it is, right? So this example that I use in the textbook, I use two things. One is caffeine, the other one is fluoxetine or, you know, antidepressant, right? So something like this is, you know, it's going to rely somewhat on domain knowledge. Same thing with genetic, genomic, all kind of stuff, right? So this is kind of like getting into the Wolfram ecosystem where it's not just computing, but it actually understands. So, you know, 20 years ago, maybe Mathematica 5 understood infinity, but certainly wouldn't understand what caffeine is. So with subsequent version, I think this is I don't know, version 10 or something, whatever. Okay, now this is something that you may not need to use right now, but I might as well put it. So just to give you an example, this thing called random seed random is a way of initializing randomization. Sometimes you want to run random experiment, but you want repeatable. So if you start with some kind of number, right, you're always going to get the, so this is kind of your random seed. You don't have to give it random seed, but I give it. Now, all it does, it's an input. The output is not something that you use. It's just a system state. It's just saying that, okay, I got it. I initialize my random number. Okay, so it's just, anyway, so this thing, previous cell call, this is used with kind of like backslash. So this is actually what's called the percentage sign. So for example, let's do this. So let's come here and say, okay, so let's do this again. By the way, I can click the whole thing. Notice this is 11 and 12, right? So if I did this and I shift enter, it re-executed the whole thing. So now it's 27 and 28, right? So if I want to go back one, I just put in here. If I want to go back two, I go here. Oops, sorry. Oops. If I go back two, I should get a two, right? Okay. Or I can actually put in the line number. So, you know, but again, line number is something that is very archaic. I don't use it ever. You will never see this 28 or something like that. Okay, you can. Occasionally, I would do this. Occasionally, I would do some kind of big graph, you know, like a plot something. Okay, and then, you know, a whole bunch of stuff, and I would get that picture, and then next to it, I would do something like export this thing. Okay, and I'll call it something like nice picture .png or something. Occasionally, you see me do this. Okay, so what happened is that I create a picture and then I export it under PNG and I can use it in my Word file, PowerPoint, whatever. I do that. So yeah, that's just about the only time you would see me use this kind of reference. Okay, it's not nice because it's yeah, it's very immediate, right? And what do you mean by 2 backslash? Okay, go back 2 step. So I rarely use it, but you can. People do that. Free form. Okay, so originally, right, every time you put in something, it's assumed it's going to be a mathematical function. Again, you add something like a word. Hello there. How are you? It's not going to know anything because you think this is you're still talking mathematics. Shift enter. Okay. Maybe I don't know what it is. Maybe it's trying to sort it out for you. It's completely nonsense. But certainly if you put it double quote, it's going to know, oh, it's a string. Okay. So this is like old-fashioned computer, right? So now, again, by default, it's this guy, language input, right? If you want to add some kind of text instead of, oh, by the way, sorry, you know, in this here, you can put text as well, but you have to do what's called comment out. So this would be like comment out, something like that. Okay. But again, Mathematica 1 probably had only this, just either function or comment out something. But pretty soon it doesn't look pretty. So they want to format this into section. And you can see I wrote the whole book, right? Has a title, chapter number, blah, 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 blah. So that's why this is kind of like very quick and dirty, but it's not pretty. So if I want to be pretty, I would use this, either plain text or format text. Okay, plain text, format text, mathematical function. Now, so you got two things, right? You got mathematical, you know, normal interface with functional program. Now here is another thing that's added recently, which is called external language, meaning that by working on this, again, you remember Python uses, if you use Python in a Jupyter notebook, right? It's going to have a kernel. Well, this is already a kernel for Mathematica. You can also do this, and I don't do this because, but you can. Let's say for some reason, you also want to do Python programming. In this setup, you can go to here, external language. Okay, except external language can be configured any way you like. For those of you, by the way, I use this example many times. For those of you who are going to health and science, if you want to dig deep into genomic, another language you should pick up is R, because that's a language that a lot of researchers has built library in. So you may work in Mathematica, but maybe there's some library about genomic data sequencing that's in R. You would go to external language. Okay. Now, external language myself, I set it to be Python. You can see this Python symbol. Okay. So now this is like a Python thing. So I can say print, right? Hello. Can I do that? Does that work, Nat? Is that valid? No. Okay, well, it takes a lot. Okay, it's every time you do something new, it has to load maybe. So yeah, I don't care. I don't want to do Python now. Okay. But certainly if you want, you can configure, if you use it a lot. I don't use it a lot. So now you got three things: mathematical language, English language, third language. Okay. What are the other two? This one I don't use a lot. Okay. This one I don't use a lot. And you can access it. You can see the shorthand of it. It's just equality sign. Just start with equal sign. This is something that I don't use a lot. This is like when you go to ChatGPT and ask it to generate a code to do something, it's kind of like a mini version of that. So if I say something like plot a sine function, oh, there it is. It just came up. Took a while. Hello. If I did this, it's an English language, natural language input. It's going to try to figure out what you try to do. Shift enter. Okay. What it does is it's a bit more clever than giving you the output. It's trying to say, is this what you want? But do it in a proper way. Plot, evaluate a sine function. If it is, okay, fine. Yeah, okay, fine. Okay, in which case, you can shift enter. Does it work? Oh, you have to put in X, sorry. There it is. Right? So what it means is this is a mathematical function. Again, this is a high level language. You talk to the mathematics, but if you can't think of it, you forgot for some reason, you forgot the word plot, you forgot the word sign language, a sign function, you can use this thing. But I rarely ever use it. You know what else I use? If I can't think of something and I want the Mathematica to suggest, you know how I do that? I go to ChatGPT. Okay. So this tool is not very useful and it's not very modern. But again, this was probably a feature in the 90s or something like that. This was the early day of natural language processing. Okay. So I rarely use this. I rarely use this. In fact, if you can't think of something and you think what you want to do, I want to plot. Let's try plot, and it's going to auto suggest. So you rarely ever need to use this kind of natural language thing. Instead, I would do this. If it's now I still do this, even though I program Mathematica for a long time and I can be considered fairly proficient in it. I would go to ChatGPT, right? Oops, how come it's not logged in? I should have this an automatically login page. Okay, maybe I sign out, whatever. But what I do is I say, in Mathematica, how do you plot a sign function? And it's basically, okay? So anyway, so this, if you kind of like want to use a natural language capability, say something like example DNA sequence or something like that, you can do that. Now, that's one equality. That's one equality. Now notice there is a super version, looks like a virus, but this was, the interface was designed before coronavirus, I think. So it looks like coronavirus. This thing, the shorthand is double equal. Now this is even better because not only is it trying to interpret what you want to do, it's actually accessing the knowledge base. It's like Mathematica plus Wikipedia. The difference is Wikipedia is an open system. It's not curated. So you can have, people can sneak in fake fact if they like, for example. But this is a curate. So this is like a semi-static encyclopedia. So if I want to sign out something, let's say Alan Turing. Now, Alan Turing is a human being, right? So you're not going to get a lot of computational thing, but let's say Alan Turing, shift enter, right? Now, just like before with this, it's going to try to confirm, is this what you mean? Because there could be many Alan Turing. Fortunately, there's only one Alan Turing that's world famous. So there it is, full name, Alan Matheson Turing, the date of birth. So these are kind of default information, his picture, his thing, his blah, blah, blah. So this is like a Wikipedia page. When you subscribe to ChatGPT Plus and add in the Wolfram, this is the engine that it gets added. So it actually gets Wolfram Alpha. Okay. But again, if you learn this, like in this class, because you're going to use it a lot, you're going to be learning the key language. You don't have to rely on prompt. Because every time you use a prompt, it's also like bilateral. ChatGPT has to guess what you want. You have to guess what ChatGPT is going to think you want, right? Whereas if you did this here, yeah, you know what you want. Mathematica knows what you want, so it's more precise. Anyway, so obviously this is a lot of text, right? It's got a little bit of Wikipedia page history. You guys guess where the spike comes in? So this is kind of 2013. I would imagine that's when the movie Imitation Game came out, right? So anyway, so this is equality, right? It's not, sorry, double equality, this kind of like COVID sign, and bring up Alan Turing. Now, Alan Turing is a human being, so not much quantitative data, but let's say something like equal Earth. Okay, shift enter. Earth is obviously very quantitative, right? Earth is a planet, blah, blah, blah. Now, the thing is, you can double click on this and you can explore. This becomes computable object, right? So you can start doing things like, okay, look up the Earth mass, and so a lot of times it's suggested, input plain text, computable data, right? So not only does it get to Earth, it gets to something maybe external data. Now I'm just gonna give example. So I've got some information here, but let's go to computable data. Then maybe it goes to something else. Oh, there is something of equatorial data, mass, moon, blah, all kind of stuff. Anyway, what I'm trying to say is, if it's common public information, instead of going to Wikipedia, if you go to here, you can do more. You can build on it, right? Because you're not copying, you're not going to Wikipedia and look up what's Earth mass radius, copy and paste in your program. Now it's actually in here. So you can do analysis on Earth's mass or, and that I think that was an example that I used before when I want to compute the Earth mass to sun mass, right? And we got something like 3,300, no, yeah, 333,000 times or whatever, okay? Bigger than Earth. Oh, it's even got a plot here. So this is Earth is here next to Venus, and okay. So these are default. These are default. This is what I mean by the spirit of scientific computation is, well, baseline, what is the landing page on Earth? What's the landing page on Wikipedia article Earth on Earth? But once you go to landing page, it's more to follow, right? Same here. Yeah, water is only 1%. Okay. So all kind of stuff. Anyway, so now you know about 4 kinds of input, right? 4 kind of. So again, this is an example I did. So plot a sine wave, it gives you this, and then you have to put your own symbol here. So I put in X. Okay. Fortune voting is the most current version. Mathematica in context, again, it's more like functional programming. You can go read more. This is very good. Actually, even if you are going to study other functional programming language like Python or maybe go to Java, you should read this page as well. Okay, so it's very clever. Okay, so where are we? Functional programming language, blah blah blah. Decorative, I already mentioned that. And this concept of entity types, again, this is the idea that big applies to mouse, big applies to car, big applies. So the general entity type, if you can apply the similar kind of action on this, it's gonna, so they generalize this concept, say, okay, fine. Instead of having just numbers, strings, built-in type like molecular data, right? Let's call this quote unquote entity. And that entity can be geographic. Okay, this is huge. This is like you can do a whole capstone project on this. You can do, entity can be geographic region. So you can do GIS data, right? So you have a entity type called country of Thailand, right? Or you can have university. So maybe entity type, satellite, rocket. So these are all entity type. So what makes it, this is in a way, even though I told you, I've been telling you that Mathematica is a bit like Python in that it feels natural as a functional programming language. You know where this idea looks like? What did it resemble? Object-oriented. In other words, if the object is tropical storm, it would have things like name. It would have things like velocity. It would have something like rotational mass or whatever, okay? If you go the word cloud, it would not have a name because clouds are not names, right? It's only types of cloud you would have names. Tropical storm will also have type. Well, it's a tropical storm, but maybe subtype. Cloud will have types, numero, cumulus, cirrus, all kind of stuff. But you might have tropical storm Cindy. Okay, that's only relevant to the object called tropical storm. So entity in this case is object oriented. Whereas cloud, you can't have cloud named Cindy because nobody names cloud. Okay. Airport will have name, will have geographic location, right? Ship, will ship have geographic location? No, because ship can be anywhere, right? It may have location of a home port. Yeah, okay, then you can do that, right? But it can move. Religion, mythology. So you can do all kind of art, and then there's going to be, it's huge, guys. Finance, all kind of stuff. Once you have this sort of like a Wolfram Alpha, the word Wolfram Alpha sort of like signify this kind of knowledge universe. Then you can get into all kind of stuff, food brand names, food manufacturer. You know, if you want to do some kind of like a marketing, compare Pepsi and Coca-Cola, you can start here, right? History, historical, grammatical units, chemical, obviously, chemical data, right? We did that already. We saw this. So now this opened the idea of entity type. This entity type is both general in the way you handle them, as well as in the way you handle them, right? It's general in the way, as well as specific in the knowledge that applies to them, right? So as this scientific community gets bigger, say let's say that geologist doesn't use Mathematica, never use, never will, never have. Maybe you wouldn't have these geographic entity types, but now they got into it, right? So now we have entity type called geographic units. Biologists, have they been playing with this? Obviously, because you have this medical, okay, biology, medical science. So you will imagine that all the multidisciplinarity that Basai is trying to teach you, math, science, computing, biology, chemistry, right? Environmental science, robotics, all kind of stuff. This is going to be in here. But obviously you have to explore, okay? You can't ask me right now what's in ICD-10. I have no idea what that is. I have no anatomical structure, so some kind of bone thing, medical tests, all kind of stuff. Mathematical, you see a lot of this, okay? I don't even know what lamina is. I think it's laminar flow in fluid dynamics, but graph and knot, finite group, a lot of this stuff are way above my head in mathematics. Anyway, so this is kind of like, let me see if I can wrap up. Go to a break. Yeah. So Wolfram Alpha here is kind of like started maybe a decade ago. And this is where you start. Oh yeah, before that, 2008. Okay. So it's not only computational, but curated data set. And now with ChatGPT, it's always also computational platform will curate plus curated data set plus access or modification through prompt with a large language model. Okay, I did this already. Solar eclipse. So yeah. So if I did solar eclipse, I'm gonna do that. So this is a page that I want to finish on the first section. Shift enter. So this is again ChatGPT plugin. Okay, so it's already. So click here, and what it does is that it doesn't just tell you what it is, it gives you example. So what happened when you prompt ChatGPT with this, you would get that. Prompt with this, you get that. Prompt with this, you get that kind of thing, right? Equation solving, currency conversion, earthquake data. I don't know how do I get rid of this? Genealogy. Anatomy. Okay, that we talk about anatomy, right? So a lot of this is based on the built-in entity type. So now that becomes a large universe of scientific computation. Okay, large universe. Now so far, okay, okay, let me finish with this. This is the last one. This is something more tangible for this class, right? Because maybe this class you're not going to go robotics or anatomical model or medical data or genomics, but let's just play with some data, okay? Some data. And data, obviously, you can go to the internet, get some data and clean it, but, and this is maybe this is going to give you a wrong impression of what life is like, because life's going to look too easy. If you go to your universe of example data, the data in here are pre-clean for you, right? Not only this is pre-clean, there's like a description. This data contains 5 million items. Each item has this many dimensions. There are 275 data point that has some missing value. You know, it has all kind of summary on it. Okay. So anyway, the universe of data is going to be easy. Okay. So I suggest for this class, you don't have to. For this class, the project, if your universe is based on example data, then life is a lot easier. Okay. But I also encourage you, if you have a conviction, let's say I want to work in sustainability problem, and I am my family runs a factory that collects so contaminant data from the factory, and I want to work on that. Obviously, that's not going to be here, right? That's your own data. Bring that to bear. Okay. But example data is nice because it has all kind of stuff. Now, this is not one file. This is a whole family. So there's geometry data, audio data, color, texture, sound, network graphs, all kind of stuff, text image. Okay. So these are huge. This is like a universe you can play with. Okay, so it's a big data set, but it's not industrial strength in the sense that, you know, if you work on industrial problem. Finally, oh, I keep saying finally. Now I'm just gonna shift enter this thing. Here's what you should do. Your project, you want to build in some kind of user interface demonstration, right? Now, what is a standard Basai solution? Some kind of sketch app or something, right? Oh, this is an app. There's a button. If you press this button, it's going to do this. It's going to do that. Well, here, you don't have to. If the button is going to do this, it's going to do that. You literally create the button that's going to do this and going to do that. Hold on. It's something with the, I'm going to cancel that. Okay. Right now, it's here. Imagine this is your app. I'm just making some funny app. Say something like predict your color. Okay. My lucky red is this. Okay. I don't like this red. Let's find another red. I don't like this red. Let's try green. Let's try blue. Okay. Something like that. This is a fun app that you did. Instead of drawing this using Sketch and say, if you press this button, it's going to randomize another red for you. You can literally make a prototype. Now, here's what I do, or I would do if I were you. This thing here, I'm doing in the notebook, mathematical notebook, right? So if I want to show it to my client, I have to carry my notebook here, right? Well, what happened here is I use Cloud Deploy. Okay, I skipped that. When I create a Cloud Deploy, where's the Cloud Deploy? There it is. Cloud Deploy this, it's going to give you an URL. That's going to be a live version of this. And you can just send this in a line group. Okay. Think of how cool that is. Yeah? You're not communicating concept, which is picture and slide and presentation. Again, PowerPoint presentation is so 2000s, guy, right? And you're not going to send the presentation slide. You don't have to send, oh, you know, look on this slide. This is the picture of what my app would look like. If you did this, it's going to go to another page. Look, it's slide number 7. And if you press the second button, it's going to look like slide number 9. No, send them this. And all you need to do is send in a basically Wolfram Cloud address. Now, because, you know, I haven't bought permanent address, what happened when I do this, it's going to create an address for this application for about 3 months, then it will just erase. But if I pay like a subscription to a cloud, you know, like you pay for Google Cloud, whatever, then I can keep this permanent. I couldn't be bothered because I don't use it that much. Okay, but you could. Okay, so it's gonna go to like a maybe Wolfram Cloud. You pay some money, keeps a permanent address, and then you get this, and then you just send it to your client. So when you do the pitch, this is not PowerPoint, guys. You literally click this, and then you can do the live demo. Now, it is a little bit slow, but you know, that's just obviously that's a limitation. So that gives you all kind of, now, this is a good place to stop. I'm sorry, it took a little bit longer. I wanted to stop halfway, but this is more like 2 hours rather than an hour and a half. Okay, we'll come back and then we start playing with the language itself. Okay, so you know that it's a language. It can do more than any other language you will ever learn in the university, right? But it's a bit of a closed system, so you don't have as many people using it as in Python. But the universe that it doesn't lack, that doesn't have in terms of user community, it makes up for in this ecosystem that's very well curated. Again, it's not the size, but it's more like a quality. Okay, size of things like you know, you go to Kaggle or GitHub, it's going to be huge, but nobody guarantees that this data is going to be clean for you. Okay, whereas if you work in the universe of curated data, okay, you won't get everything you want. Okay, but you can be sure that the data, because it's curated, it's clean. Basically, it's clean. Okay, so again, so this part here about this cloud deployment is very useful because you don't have to carry the presentation deck anymore. You can just line your client and say, hey, go check this out, go to the URL, and it's gonna get to play with exactly what you want to show. Okay, so let's take a 5-minute break.